Welcome to Math Hub S. Today we are going to look at the topic rational functions. So if you are interested in understanding rational functions, then you can journey with me as we go through this particular topic. When we talk about a rational function is a function of the form p of x over q of x, where p of x and q of x are polynomial functions right? And q of x and q of x is not equal to 0. So when we say a rational function, it is simply a function of the form p of x over q of x, where p of x and q of x are polynomial functions. And then we are saying that q of x is not equal to 0, because if q of x becomes 0, that is going to make the function undefined. And therefore, this one here, q of x is not equal to 0, right? We are also saying that p of x and then q of x are polynomial functions, that is this, and then these are polynomial functions. A polynomial function is a function of the form axn, then plus bxn minus 1, then plus cxn minus 2. Now we can continue the process so we get to a certain a0, where a0 is a constant, right? So that is what we mean by a polynomial function. And then an example of a polynomial function is x cubed plus 2x squared plus 10x minus 5. And you can see that the highest degree is 3, and then you have the n here. The n standing for the highest degree. Probably you can see here I have, this is exponent 2. So you have the highest degree has been decreased by 1, and you can see that here the 3 has been decreased by 1 to give us 2. Then here the highest degree has been decreased by 2. So the exponent of the x here is also 1, which means that the 3 has been decreased by 2 and giving us 1. And then we continue a constant. The a0 here standing for a constant, and then we have a constant here as 5, right? We can have an example number 2 of a polynomial function. We have minus x4 minus 3x plus 5. This is a polynomial. We also have a simple polynomial as x plus 1. This is a polynomial as well. So all these functions are polynomial functions, and we are saying that a rational function is a polynomial function over a polynomial function. That's basically what we are saying. So we have p of x over q of x. So if you have a rational function, then it is a polynomial function over another polynomial function. That's what we mean by a rational function. Example of a rational function is x squared plus 2 all over x cubed minus 10. This is an example. We also have x cubed plus x squared minus 1 all over x squared minus 1. This is also another rational function, and we have countless rational functions, and we can add one more, x plus 3, then we have x squared minus 2. All these are rational functions. We have basically proper rational function and then improper rational function. So we have proper rational function, rational function. And then 2, we also have what we call improper rational function. Improper rational function. If you look at the rational functions, you see that they are fractions. Just as we have proper fractions and then improper fractions, so do we have proper rational functions and then improper rational functions. You know that a proper fraction is a fraction where the numerator is less than the denominator. Example is 1/5 is a proper fraction. Then we have 7/15. All these are proper fractions. Now when we talk about improper fraction, then we have fractions like 10/7, 13/2. So an improper fraction is a fraction where the numerator is greater than the denominator. That is what we call improper fraction. Then a proper fraction is the one that the numerator is actually less than the denominator. Now if we look at the rational fractions or functions that we have here, we use the degrees. The degrees are the powers. We use the degrees to determine whether the denominator or the numerator part of the rational function is greater. So here you see that the degree here is 3. You have x cubed, and then the top we have x squared. So since 3 is greater than 2, we are saying that this one here is a proper rational function. This is a proper rational function. If we come to the second one, we have the degree of the numerator. The highest degree of the numerator is 3. This is the highest degree, 3. Right? Then the highest degree of the denominator is 2. So you see here 2. And we see that 3 is greater than 2, which means that the numerator is greater than the denominator. And since the numerator is greater than the denominator, we are saying that this is improper rational function. So this is improper. Now if we come to the next one here, you see that here it is just x. X means that it has a degree of 1. When the degree is 1, we do normally write it, right? So this is a degree of 1. Then also here we have the degree to be 2, and that this degree of 2 is greater than the degree of the numerator, which is 1, and therefore this is a proper rational function. So this is proper. So you can see, just like in the cases of fractions, when the numerator is less than the denominator, we call it a proper fraction. It is the same thing applied to the rational functions. Also, if you divide a number by 0, this is undefined. This is undefined. Any number at all dividing by 0 is undefined, right? And then, which means that we don't divide, which means that if you divide a numerator by 0, you will not get a value for yourself. You won't get an answer for yourself, right? And we call that undefined case, or it is undefined, right? Also, we are saying that a rational function is a function of the form p of x over q of x over q of x over q of x. Then, because we don't divide numerator by 0, we are saying that q of x should not be equal to 0. If this denominator here is 0, the whole rational function becomes undefined. And because of that, we are saying that q of x should not be equal to 0. Now, we have what we call the domain of a rational function. Domain of a rational function. Domain of a rational function. Rational function. Domain of a rational function is going to be our next topic on the discussion. So please subscribe to the channel for more buttons and also share the links. Let's build the channel together. Thank you.